The invention relates generally to the capturing of available electromagnetic energy using a device and method for creating an electromagnetic force, and then using the available stored energy for recycling into the system as stored energy. The method of creating a back electromagnetic force is a result of coupling and uncoupling a coil to a voltage source. As a starting point, an arbitrary method in describing this device will be employed. Namely, the flow of electrical energy and the mechanical forces will be tracked from the energy's inception at the primary battery to its final storage in the recovery battery. Figure 1 is a perspective-sized view of monopole motor according to an embodiment of the invention. As shown in Figure 1, electrical energy from primary battery 11 periodically flows through power switch 12 and through power coil wiring 13A. In one embodiment, power switch 12 is merely an on-off mechanical switch and it's not electronic. However, the switch 12 might be a solid-state switching circuit, a magnetic reed switch, a commutator, an optical switch, a Hall effect switch, or any other conventional transistor or mechanical switch. Coil 13 is comprised of the three windings: power coil winding 13A, trigger coil winding 13B, and recovery coil winding 13C. However, the number of windings can be more or fewer than 3 depending upon the size of the coil 13, size of the motor and amount of available energy to be captured, stored and used as measured in watts. Electrical energy then periodically flows from power coil winding 13A and through transistor 14. Trigger energy also periodically flows through variable resistor 15 and resistor 16. Clamping diode 17 clamps the reverse base emitter voltage of transistor switch 14 at a safe reverse bias level that does not damage the transistor. Energy flows to stator 18A and pole piece 18B, an extension of stator 18A. Pole piece 18B is electrically magnetized only when transistor switch 14 is on and maintains the same polarity as the rotor poles 19, north pole in this instance, when electrically magnetized. The north rotor poles 19A, 19B and 19C, which are attached to rotor 20, come in momentary opposition with pole piece 18B, creating a momentary monopole interface. The poles 19ABC, which are actually permanent magnets with their north pole facing outward from the rotor 20, maintain the same polarity when in momentary alignment with pole piece 18B. Rotor 20 is attached to rotor shaft 21, which has dry pull A22. Attached to rotor shaft 21 are rotor shaft bearings blocks 31A and 31B, as seen in Figure 2. As rotor 20 begins to rotate, the poles 19A, B, C respectively comes into alignment with magnetized pole piece 18D in a momentary monopole interface with energy flowing through diode bridge rectifier 23 and capacitor 24. The number of capacitors may be of a wide range, depending upon amount of energy to be temporarily stored before being expelled or flash charged into recovery battery 29. Timing belt 25 connects drive pull A22 on timing shaft 21 to timing wheel 26. Attached to timing wheel 26 is contact rotor 27, a copper insulated switch that upon rotation comes in contact with brushes on mechanical switch 28. That the means for counting the number of rotor revolutions may be a timing gear or a timing belt. Finally, the available energy derived from the back electromagnetic field that is stored in capacitor 24 is then discharged and stored in recovery battery 29. Figure 2 is mechanical perspective top view of the monopole motor of the instant invention without electrical circuitry. Stator 18A consists of coil 13, which is comprised of three separate coil windings: power coil, winding 13A, trigger coil, winding 13B, and recovery coil, winding 13C. Pole piece 18B is at the end of the stator 18A. As rotor 20, which is attached to rotor shaft 21, rotates, each pole 19 respectively comes in momentary monopole interface with pole piece 18B. The polarity of pole piece 18B is constant when electrically magnetized. Rotor shaft 21 has rotor shaft bearing blocks 31AB attached to it for stabilization of rotor shaft 21. Attached to rotor shaft 21 is drive pulley 22 with timing belt 25 engaged with it. Another means for timing may be a triggered timing gear. Timing belt 25 engages with timing wheel 26 at its other end. Timing wheel 26 is attached to timing shaft 30. Shaft 30 is stabilized with timing shaft bearing block 32AB. Attached to one of timing shaft 30 is contact rotor 27 with brush 28A, which upon rotation of timing shaft comes into momentary contact with brushes 28B, C. Figure 3 is a block diagram detailing the circuitry of the monopole motor. Block 40 represents primary battery 11 with energy flowing to coil block 41, which represents coil winding 13 ABC. From coil block 41, energy flows into three directions: to trigger circuit block 42, transistor circuit block 43, and rectifier circuit block 44. Energy flows from rectifier block 44 to storage capacitor block 45, with energy flowing from block 45 to both recovery battery block 46 and rotor switch block 47. Referring to figure 1, the operation of the motor is described according to an embodiment of the invention. For purpose of explanation, assume that the rotor 20 is initially not moving, and one of the poles 19 is in the 3 o'clock position.